instance, a modular design of all the parts that should be available for making the whole construction. Then I want to say a few words about oil palm, because I've been to Malaysia. Because of that, also Nico already mentioned about a large amount of biomass that is not being used. Here's some figures we have been looking at. There's 46 million tons palm oil per year in 2010. 25% of the world's vegetable oil production. It's a very big crop. There's a big expansion in the last 20 years from 2 to 7 million hectares. And 80% of the world's production is in Malaysia and Indonesia, so that's quite obvious. This palm oil is a big thing in Malaysia. But if you look at the palm oil and the palm kernel oil, the only products, that's 9% of the biomass is actually produced by the plant. The rest is being wasted, I would say. If you look at what kind of waste is there, this is the empty fruit bunches. This is the way the material is being burned in the boilers to generate the energy, which is basically more to get rid of the material than I would think than the energy for the production. Of course, there's energy needed, but there's surplus. And this is the problem where emissions of the methane gases occur. What are the residues there? That is the fronts on the field. That's 10.5 tons per hectare. The trunks, that's 70 tons per hectare per 25 years. Then there's the residue at the palm oil mill. That is the empty fruit bunch. That is 1 ton per ton palm oil produced. Mesocrop fiber, that's 0.6 ton. Shells, effluents. Dry matter, that's different values, but depends on the efficiency. And that's only partly used as fuel. So what is interesting then to use as raw material, that would be the residues. You can make biodiesel, of course, from the oil that is being extracted from the pressing cakes, or when you look at the empty fruit bunch and you extract it, there's still 13% of oil in those. And if you ferment those, you can make biogas, you can make hydrogen, you can make acetone, butanol, and ethanol for fermentation. You can think of making biopolymers from that. That's polylactic acid or polyhydroxyalkanoate. And you can make pyrolysis oil. You can make charcoal, fibers for paper, but also building boards and composites. Of course, that's one of the interesting areas here. You can even further refine. You can go to cellulose. And the cellulose, you can make cellulose plastics. You can make cellulose derivatives. You can make nylon boards like we did for the palm oil, for the coconut. And you can make green chemicals, and that could be, for example, from the pentosome problem that was mentioned. You can make glues from these pentosomes. So, to increase the efficiency, I think there's a big opportunity that palm oil residues are being used more efficiently. And I think this would help a lot to make the palm oil more sustainable. Well, this is information I suppose most of you already collected. Only a little bit of it is burned at the mills, and it's now banned. So we have been looking in much detail in the empty fruit bunch, If you want to use low-grade values, it will be fuel ethanol for rising would-be particle boards or composites. You can even increase that. You can make paper pulp, paper boards. If you want to increase the value, you can even go to dissolving cellulose to make textile fiber. You can make cellulose derivatives like cellulose acetate or cellulose, other cellulose esters and ethers. So my conclusion would be that application of renewable building materials is technically very good, feasible. And now it's more labor intensive and more expensive, and that's largely because it's not a large-scale industry. It's small-scale production. If you would have systems available for supplying building materials, it would be a very good chance for biomaterials. I think there's a lot of need for contests like this to demonstrate new ways of building. Ecological building has a broad public interest. At least in Europe, we notice this is occurring. There is research needs for making renewable building materials a major product. So innovation of building systems is required. That also requires other design. Supply chain is a very important issue. Where do you get your raw materials from, and who is going to produce your bio-based building materials? An issue is the indoor climate control. If you have bio-based building materials, the indoor climate is affected, and it could be much more pleasant than the climate we have now. And nobody wants to touch upon this because they know much more about the indoor climate of big growing farms than the indoor climate of the human dwellings. Another research issue would be the functional lifetime of the materials. So the protection against moisture, fire, and degradation is something that needs attention. And there is ways of doing that. There's possibilities to increase the barrier for microorganisms, but still this is something that's research needed. And of course the building system should be fitting in the current building practice. So I suppose there's a lot of education needed, and therefore I think it's a good chance that we have here today to show and to inspire you. So product promotion and publicity would be the next phase, I would think. And regarding the biomass production, the byproduct utilization added value is very beneficial for the sustainability of the palm oil production. Essential for certifying the sustainability of the palm oil, biomass, energy and products in the future, I would think. To make this work, multi-stakeholders involvement is needed, including outsiders, non-food industries involving in this palm oil industry. So my conclusion at the end would be there's no need for waste when it's bio-based. Thank you. There's some time for questions, I was thinking. Yeah?